Embedded controller lab uh, pulse width modulation experiment we will go through. Uh, we have used Arduino environment when a question was imposed, like in case if you want to drive a DC motor using Arduino programming, Blink program could also be dumped, and same program when you connect, rather than you connect a pin to the LED, you can connect the pin to the DC motors one end, and another end you can ground it, so that to some extent your DC motor will run, provided it takes low voltage. Speed is not great, but the way it runs, it is uniform. You cannot control the speed. Now suppose if the question is posed, like if I want to control the speed, if I want to change the speed of the DC motor, then what could be done? So we cannot afford to use command digital write. Digital write was actually the function which you were using in case if you want to trigger a DC motor. Okay, so there is one more function which is analog write. So analog write function in Arduino, if you go in depth, it says that you are using their PWM signal. Rather than sending high or low pulse, you in turn send a PWM signal there. So pulse width of the pulse is modulated, it is changed, you call it as a duty cycle. So different duty cycles are given. For 2 seconds you give one duty cycle, after a while give one more duty cycle, so the speed could also be controlled. So this is actually the concept which is used in case if you want to control the speed of a DC motor. So same experiment we will look at. Before that, let's look at what is this PWM, how many PWM pins you have in ARM controller, and is it single-edged PWM pulse you have, or else is it double-edged PWM pulse you're having. So in ARM controller you are having 6 PWM output pins. So six PWM signals we will get it through the pins, and those pins what they are we will address it, and all are the 6 pins which we just addressed are single-edged. 6 single edge. In that mode we can use, or it can also be used in a 3 double edge. Now what is single edge or what is double edge? So when you look at this figure, um, in this case the first figure, you call this as a trailing edge PWM. In trailing edge PWM, the leading edge, which happens to be this one, rising edge, this leading edge is fixed, whereas the trailing edge is modulated. This is made to change, so you can decrease, you can increase, so duty cycle will be varied, so hence the name trailing edge PWM. Similarly, you have one more mode, leading edge PWM. So in leading edge PWM, what we do is the trailing edge is kept fixed, and the leading edge is made to change. The leading edge is made to modulate, so the name leading edge. And in double edge you can modulate, or you can change this either from the trailing edge, or you can change it from the leading edge. So both modes, both edges you can use for varying the pulse duty cycle. So here we are using a trailing edge PWM. So this is a single edge PWM. In single edge PWM, these are the two types. Okay. Now let's look at the pins which we need to concentrate. Suppose if you want to work with PWM. So port 2 we need to give importance to. In port 2, port 20 to port 25, this many lines, this many pins belonging to port 2 could be used for PWM signals. To generate PWM signal, we will be using this pin. So now suppose if you want this pin to be used as PWM, then you have to modify the content present in pin cell 4 register. Why pin cell 4 register? Because pin cell 0 and pin cell 1 registers are used for programming the pins port 0. All pins, 32 pins of port 0, if you want to programming in the sense here, for using it for some other application, we know every pin belonging to each port could be function, it could be behaved in different manner. So each pin is multifunctional. So here port 20, if this pin cell register isn't used, then it will work as GPIO. That is, if the content which we place on the bit 0th bit and 1th bit, if the content is made 00, then it will work as GPIO. Suppose if I want it to behave as a PWM output, then 0 and 1th bit should be made, 0th bit should be made 0th bit should be made 1 and 1th bit should be made 0. Okay, so the value should be 1 itself. I repeat, 0th bit you make it as 1 and 1th bit you make it as 0. So that becomes second function. Third function is txti, and fourth function is trace data. We will not concentrate on this. Here, ensure that the bits, first and second bits, bit number 0 should be made 1, bit number 1 should be made 0. So 1 should be the value which should be loaded onto this pin cell 4 register. That would set this PWM1 channel. Similarly, PWM2 channel if I want to use, then you will be working on second and third bit of pin cell 4 register. For the first case, we will not use this 5 PWM channels, rather we will be using PWM1, first channel, PWM channel, we will be using it. Okay, now let's look at what are the different registers which you have, which needs to be modified when you are working with PWM. So these are the set of registers which needs to be programmed if you use PWM concept. So in this, only the registers which we will be making use, I'll just make a note. So others we will not use it timing. IR register is not used for in our program, so we will not discuss this. Okay, then TCR register we will use. TC is actually the register which is altered based on this TCR register, so we will discuss this. Then we have PR and PC register. We will not talk about this too. They are used for dividing the clock. Pre-scalar register it is. MCR register we will be using. So MCR stands for match control register. Every channel in your PWM signal, every channel in your PWM signal is associated with a match register, which we call it as MR0, MR1 to MR6. So MR0 is used for loading the time, maximum time, cycle time which we use, and here in this register we will load the duty cycle. Like you want 10% duty cycle, 20% duty cycle, 50% duty cycle, all those values we will be loading in this register, and this will be having the T on plus T off time. This will have just the T on time. And PCR is for controlling the PWM register, and LER is load enable register. So I repeat, we will be using TCR register, MCR register, PCR register, LER register, and the match register for your particular PWM. First program we will be using PWM1 channel, hence MR1 we will be using, but MR0 is common, wherein we will be loading the cycle time, maximum cycle time, that is T on plus T off will be loaded in this. Right, now let's discuss each of this register content and what it should be for this particular program, what is its content should be. So first we will discuss TCR register. So this is called as timer counter register. So this is used for incrementing the timer register, which is known as TC, timer counter register. Okay, this is timer counter register. You have a timer counter, which again is a 32-bit register. Its content has to be automatically incremented. So to self increment the content of timer control register, TC register, we will be using TCR register. So here, if you want to increment the counter, then we will be using this bit. TCR bit number 0 will be used, and if you set this bit, then the counter, which we call it as a timer counter, TC register, will keep on incrementing. It keeps on incrementing till it reaches the corresponding match register, which it will be compared later with. Okay, so I repeat, this bit should be equal to 1, and we can make use of bit number 2 also, but it is not reserved here. It should be interchanged. So PWM enable position is this second bit, it is PWM enable. So even if you're not using this PWM enable, the program will completely work. So if you are using this bit here, so the remaining content will be 0, which means this should be 1, this bit should be 1. So the value which you can load onto TCR register could be 5. You are enabling it. Even 1 will also work. So remember, the bit number 0 should be always 1. So for the program we can use 5 or 1. So I suggest you to use 1. So we will not give importance to PWM enable. So this PWM channel block is already, it will be enabled when we use PCR register. That is actually the register used for enabling or disabling it. Okay, so that's about TCR. So TCR content should be 1. Okay, the next register which is associated with PWM is match control register. This control register, its job is to ensure that whenever this name suggests match control, so whenever there is a match between TC, so what happens, TC is a timer control register and it keeps on incrementing till it reaches the match control registers content. So here you have how many match control registers altogether? Match register 0, MR0, you have MR1, you have MR2 till MR6. So altogether you have 7 match registers. MR0, in MR0 we will be loading the T on plus T off time, that is the maximum cycle time will be loaded in MR0 register. Now let us assume that MR0 is loaded with the value 100. So TC starts from 0, and when it reaches 100 we want the timer control register TC to be automatically reset to 0. That is once a whole duty cycle is complete, then again you have to reset this timer control register to provide one more duty cycle. So we will be using the bit, that is this bit, PWM match register 0. Match register 0, if you are setting it as 1, then automatically it will compare the value present in MR0 register with the TC content. If TC matches the content of MR0, then automatically the TC content will become 0. It will get reset. So all other bits are not important. We will just concentrate on this register PWM MR0 reset. Okay, so I hope this is clear. So MCR content should be 1, has to be, others you can make it 0. So it will be 2. 2 will be the value of MCR register. Third register which we will use is PCR register. So this is to select the PWM channel and or enabling the PWM output. If you want to enable a particular PWM channel, then you can use this PCR register. And here we will not use 0 to 8 bit. This is for selecting channel, either is it single edge or double edge. For selecting that we will be using pin number 2 to pin number 6. Already I have told you we will be using single edge mode for PWM channels. So single edge mode, you can set all the bits to 0. So if you want it to work in a double edge mode, then you have to set it as 1. So we will be using all bits 0. So single edge it works, and just give importance to this bits, 9th bit onwards to 14th bit. So these are actually the bits used for enabling your PWM output. So we are interested with PWM1, PWM channel 1, PWM channel 1. For that, to enable that channel, the 9th bit of this PCR register should be 1. So if you want to enable PWM second channel, then the 10th bit should be 1. So for this application we will be using PWM channel 1. So for PWM channel 1, its respective bit position is 9. 9th bit position should be made 1. So you make 9th bit 1 and remaining all bits you make it as 0. That is the value which you need to load it onto the PCR register. So it becomes 0x 5 zeros followed with 200. That will be the value which will be put on this PCR register. The final register which we will look at is load enable registers. So this load enable register you will be using to match the value. For example, in the this program, we will use two match registers, MR0 and MR1. So MR0 content, if this is made 1, what it does is once the matching takes place, after it gets matched, like MR0 content will be compared with the timer control register. Once the match takes place, then the timer will be reset, and we want when you are placing a new value, onto the match register, then this len register should be made, it should be enabled. I repeat, now let us say that the duty cycle is 40%. 40 is actually the value present in MR1. So in MR1 register we will be loading the duty cycle, and MR0 will have 100. Let us say that is the whole time, complete duration. Now as soon as PC reaches MR0's content, so it will automatically change the value of timer control register. So in that case, if you want to reload a new value, new duty cycle onto the register MR1, now the duty cycle is 40. After a while I want the duty cycle to be modified, because duty cycle you are supposed to modify. So 50 I want. So if that 50 needs to be enabled, then you have to change the value each time you provide a duty cycle. Then you have to use this len register, wherein the particular match register which you are using should also be made 1. So for example, in this case we are using MR0 register and MR1 register. So make sure that these two bits are 1 to load a new value onto the match register. Once the duty cycle is created, it creates the duty cycle, the data or that signal gets passed on to the line PWM, then again a new value of the duty cycle which you want to be highlighted. If that needs to be created, then you have to enable this load enable register, that is for adding the new match value onto the register. Okay, so we will use this registers, all this register. So this 2 we will make it as 1. So when we make this 2 bits as 1, the answer which you are going to get is 3. So that's your content. So I repeat, TCR register we should know, PCR register we should know, MCR register we should know, LEN register we should know, and finally the match register contents which you are using. So MR1 register we will use here, because that is a register associated to PWM channel 1, and that register content should be equal to 0 first. So we will say that there is no pulse width is 0. For that we will initialize the value of MR0 to 0, MR1 to 0, and MR0 we will set it as 100. Let us say that the period is 100, that is t on plus t of time. Fine. Now let's look at the pictorial diagram. Says that you have a controller, and this has a DAC. Probably you are aware with the DAC module which you have used. So in the same DAC module can also be used. So in the same module, PWM signals are also created. So you have a pins through which you get PWM signal. So you using a DAC module connected to a CRO and interface your controller with the DAC module. So that's the communication that you need to look at. Okay, the working of this PWM signal also as addressed, since we are using PWM1 channel, MR1 will have a duty cycle and MR0 will have the cycle time. So 60% efficiency I want, 60% efficiency I want. So in that case, you use this configuration. So initially, when the value of what happens initially, we can think as if it is high, it is in the previous state. So timer counter register, first it will be 0, then it will become 1, it will keep on changing the value. As soon as it reaches the MR1 register content, that is when it reaches 60, then this comparator, which was initially connected to set stage implies it is high. It is high, it was high till 60, it was high. Oh, that is the old state. And once it reaches the value 60 TC content, then the comparator generates a signal because both are matching. When it is equal, then it is going to send a pulse, reset pulse. So this was high till 60. After 60, it becomes low. So it keeps in this state till the timer counter is lesser than 100. Okay, so timer counter 60, it will be pulled down. This becomes high to low, it becomes, and it continues in the state. And also the timer counter register content keeps on updating. Once it reaches the whole cycle time, which is 100, then when you're at this point, then this pulse which was triggered low will be pulled high, which means you get the previous state, that is high state you'll get. So this gives you one duty cycle, that is 60% in this case. So here 60% was the duty cycle. Then again, once it resets, then you can reload a new value into the MR1 register. So it creates one more duty cycle. Okay, so this is actually what you are supposed to do, and this is the concept used in PWM. Okay, so just to recollect back, what and all things you need to do and what will be the value. So the first step, what needs to be done for configuring PWM is to select the channel. PWM channel, PWM1 channel we are supposed to use, and that is equal to P20 itself. So to make it PWM1, we will be using pin cell register, and the content which we need to load in pin cell register, pin cell 4 register is 1, remember. Then we will be using timer control register. In timer control register, we can either use 1 value or we can either use 5 value. So here in this context, we will be using the value 1. Okay, 5 is also fine. PWM enable, we will try to avoid it. Then PR we will not be using, so we do not have to worry about this prescaler registers because we don't use PR registers. Okay? And the next register which we have here is match control register, and I just told you second bit has to be made 1. So when you make second bit as 1, the value which you will be loading onto the register is 2. So this is to ensure that timer counter becomes 0 as soon as you have the value present in TC when it is matching the content what you have in MR0. In that case, we want TC to be made as 0. So that is done with the help of this value. So set the value of MCR to 2. Then we have MR0 value. Cycle time we need to load it on the register MR0, and the MR1 you will load the duty cycle. So duty cycle initially we think as if there is nothing signal sent. So duty cycle is 0. Then we will keep on incrementing the duty cycle till we get the maximum duty cycle 100. Okay, then final register which you'll use is LER and PCR register. So what should be the value of LER register? LER register you can load the value 3 because the last 2 bits, LC least significant 2 bits, we will make it as 1. So that is to ensure that your match control register when it gets a new value. To load a new matched value onto the register, we will be using these 2 bits, and 2 registers which we will be using is MR0 and MR1. So those 2 bits needs to be set. And the PCR register, as I've told, we need to concentrate on the 9th bit in the PCR register, and 9th bit in the PCR register is to enable your PWM1 channel. Fine. So let's look at the program finally. This is your program written. So what do you have? This is your device, LPC17XX device, and we are using a delay. Why delay? Because once you provide a duty cycle, after creating one duty cycle, we need to vary it. So we will wait for a while, then we will change the duty cycle. Let's not it goes continuously. Don't try to change the duty cycle without giving a delay, so it doesn't look good. That's why provide a delay, then you can visualize the output properly. Okay, so here we just use one value of n, and this n will be set to 50 in the program, which means it will execute this set of code will be executed total number which is equal to 50 into 500 number of times. 50 into 500 number of times this loop gets repeated, executed, so you have a delay to it. So if you want to change the delay, you can modify either the inner loop count or outer loop count. So this can also be altered. You make this 550 into 500. In that case, you can use only one loop, for loop. Fine. Then we have a main program. So as told, you have to use pin cell 4 register, and the content present in pin cell 4 register should be 1. Fine. Then we use the TCR register, and I've told you this can be 1, this can be 5 also. So we will use 1, no problem. So what is this pin cell? How do you get pin cell 4 register? So it is available in the library LPC pincon. Fetch the module present in the library LPC pincon, and that method is pin cell 4. Then again fetch the module TCR register from the module LPC PWM. Similarly, all these registers needs to be picked from the module LPC PWM1. So only this one is to select the PWM signal. Others are there in the PWM signal. There's many components you call are the associated registers with the PWM. So this many you have, all you need to use. Right? Now the program, how it works. So first, as addressed, MR0 value, MCR0, match control register 0, and MCR1 value has to be set as 0. So here, okay, I think this should be MR0, it is not MCR, my mistake. It should be MR0 and MR1 register, match register 0, match register 1. So here, first what we do is we set the duty cycle to 0. Set the duty cycle to 0 till it reaches 100, because maximum duty cycle which from this program you can get is 100. So 0, you have the first value till it reaches 100. Repeat this process. So what you are gonna do is, so first on to this line PWM, you are sending MR1 signal. So when MR1 signal is sent, okay, so this enables this automatically the PWM channel 1 is enabled, and when you provide this duty cycle, the graph what you're gonna get will be something like, so here MR1 is 0 now, and MR0 content we have taken it as 0. So what happens, so at the beginning itself timer counter is 0, so it matches. So what happens, nothing you get. So the previous content, whatever it is, if it's high, then automatically it will be pulled down to low, because there is a match. There is a match with respect to MR1 and MR1 and TC register, because 0 is the first value of TC and it matches the MR1 value. So automatically it will be low. It will be brought low, and it will continue that position till the timer counter reaches the value 100. So once it reaches 100, then what you do is you have to reload MR1 with the new value. For reloading a new value into the MR1 register, we have to first use LER register. LER register has to be enabled. Then we will pass a new value on it. So now the new value, if it's set to 1, then what happens, initially TC will be 0. Then when it becomes 1, you get a small pulse. You get a small pulse with duration as 1 cycle. We can take it as 1 unit. 1 unit will be the duration, and soon after that it will be triggered low. It will be triggered low, and for the next 99 units it will remain low. Okay, then again what happens, again when the match happens between the TC register when it is 100 and when this is also 100, again it will be pulled to high. So now what happens, again MR0 value, MR1 you have to reload. So for that again you will be using LER register. Now you will be using MR1 as 2. So when you observe, when you iterate this again and again, you can figure out the duration of pulse is keeping on varying. Starts from 0, becomes 1, 2, so on till it reaches the duty cycle. It increments. So you'll get the duty cycle of the pulse. Okay, the duty cycle is varied. Okay, so that's what is expected. So it is going to increase here. The duty cycle is low, keeps on increasing, becomes maximum. Now what if I want it to be decreased in the same manner in which it was increased? So in that case you can use one more for loop. So this loop is for uh, incrementing the duty cycle. Then once it reaches the maximum value 100, then you can decrement the duty cycle. So the graph would look something like this. So if I plot this way, so I'll just we'll see this with the respect to itself. So initially no pulse, then slowly you get one pulse, then two pulse, then remaining duty cycle 3 pulse and 97, 4 pulse, 96, and 5 pulse and 95, so on. It keeps on repeating. Finally when it becomes 100, then again it goes in this manner, then it becomes 99, then it becomes 96. Okay, so pulse width is altered, it becomes more, it also gets reduced. Okay, so that is what the program is about. So the next we will discuss the next program, which is DC motor, how to control the DC motor, speed of the DC motor using the PWM signal. Hope the program is clear. Okay, thanks.